All right, let's jump right in. Look, we are all swimming in a sea of data every single day, right? But the big question is, how do we turn that chaotic mess of numbers into something we can actually understand and use? Well, that's exactly what we're going to figure out.
We're surrounded by it. Test scores, sales reports, survey results. But when you first get your hands on it in its raw form, it's really just noise. It doesn't tell you a story. To get to the meaning, we need to do a little detective work.
I mean, just picture looking at a massive spreadsheet, right? Thousands and thousands of numbers. It is completely overwhelming. You can't see any patterns. You definitely can't see the big picture. It's a classic case of information overload.
Now, contrast that giant mess with this. A single, elegant number that tells a huge story. A batting average of .333, you instantly know that player gets a hit about 1 out of every 3 times. Or think about a GPA. It's the same idea. That's the real power of boiling data down.
And the tools we use to work this magic? They're called descriptive statistics. You should think of them as your official data detective toolkit. These are the things we use to crack the case, to solve the mystery hidden inside all those numbers.
And here's the best part. You don't need to be a math whiz to start making sense of data. You just need a framework. And for our investigation, it all comes down to 3 key questions. What's the shape? Where's the center? And what's the spread? Let's tackle them one by one.
First up, the shape. Before we start calculating a single thing, we just need to see what we're dealing with. Visualizing your data is kind of like getting a drone's eye view of a landscape. It shows you the whole pattern, the peaks, the valleys, and where everything is clustered together. So one of the easiest ways to start seeing that shape is with a frequency distribution. It sounds fancy, but it's really just a simple summary table. It just counts how many times each value, or in this case a range of values, pops up in your data. It's the first step to turning that chaos into neat, tidy categories.
And this is where it gets cool. When you turn that table into a simple bar chart, what we call a histogram, the shape of the data just bam! It instantly becomes clear. You can see right away that the 46 to 55 age group is the biggest one. The picture tells a story that the numbers by themselves just couldn't. But, sometimes that shape can be a little lopsided. This is something we call skewness. And it happens when a few really extreme values, way out on one end, literally pull the tail of the data's shape to one side. Now hang on to that idea of skewness because it's about to become really, really important.
Okay, on to our second big question, finding the center. Once we have an idea of the shape, we want to find a single number that can represent the typical value in the whole dataset. This is what most people are talking about when they say the average.
And in our detective toolkit, we've got 3 main suspects for finding the center. First, there's the mean. That's the mathematical average we all learned in school. Add them up, divide. Then you've got the median, which is the value smack dab in the middle when you line everything up in order. And finally, the mode. That's simply the value that shows up most often.
Now, in a perfect world, if your data made a beautiful, symmetrical bell-shaped curve, all 3 of these measures would point to the exact same spot. They'd all agree. But let's be honest, the real world, it's rarely that neat and tidy.
And that brings us to a really fun plot twist. Because the most common measure of average, the mean, can sometimes lie to you, especially when your data's shape isn't so perfect.
So, let's imagine a small company with 9 employees. If you calculate the mean, or the average, annual income, you get $50,000. And if you find the median, the person right in the middle, you also get $50,000. Perfect! They tell the exact same consistent story about a typical salary. But watch what happens now. We keep those same 9 employees, but the CEO, who makes, say, $5 million a year, joins the group. We've just thrown in an extreme outlier, one single number that is wildly different from everybody else.
And would you look at that? The mean income skyrockets to over $500,000. It's completely distorted by that one huge salary. It no longer represents what a typical person in that group actually earns. But the median? It's still sitting right at $50,000. It points to the true middle, totally unfazed by that billionaire CEO.
So here's the absolute key takeaway. The mean is super sensitive to outliers, while the median is robust. It holds strong. This is exactly why when you see reports about average home prices or incomes, they're often using the median. It just gives a much more honest picture when the data is skewed.
All right, time for our third and final question. Knowing the center is great, but it's not the whole story, not even close. We also need to know how spread out the data is. Are all the numbers clustered tightly around that center, or are they scattered all over the map?
The simplest way to get a sense of the spread is the range. You just take the highest value and subtract the lowest. It's super easy, but it's also a bit crude. Just like the mean, it's totally thrown off by those extreme outliers, so it can be pretty misleading.
A much more powerful tool is the standard deviation. Now, the formula can look a little intimidating, but the idea behind it is actually super simple. First, you find the center, our old friend the mean. Then, you measure how far away every single data point is from that center. And finally, you take a special kind of average of all those distances. That's it. The final number tells you the typical distance any given point is from the average. A small number means your data is all tightly packed. A big one means it's all spread out.
And there you have it. We have just assembled our complete Data Detective Toolkit. By combining what we've learned about the data's shape, its center, and its spread, we can finally go from that confusing jumble of numbers to a clear, complete story.
So, let's put it all together. We always start by asking about the shape to see the data's pattern. Then, we find the center to locate the typical value, just being careful to pick the right tool for the job, mean or median. And finally, we measure the spread to understand how diverse the data is. Put those 3 clues together, and you've solved the case.
And that is the real power here. These tools don't just help us understand one pile of numbers. They give us a shared language to summarize, and more importantly, to compare different groups, whether we're talking about 2 different baseball players or the test scores from 2 different schools.
So I'm going to leave you with this final thought. The next time you see a headline that reports some average number, you'll know that's only 1/3 of the story. You'll know to ask 2 more questions. Yeah, but what was the shape? And just how spread out was it?